What is up? Today is a very symmetric day. We are working on section 2.4, and this will be day 1. We'll spend 2 days over it. But check this out. Symmetry, yes. I think just looking at things, most PreCalc students are able to verify whether or not a graph is symmetric. You just got to look at it. When it says symmetric with respect to the y-axis, this is an example here. You can see that it folds. It would, if you folded the graph on top of itself, creasing it at the y-axis, then you would see that this part, this left half, would line up with this right half. It's symmetric. It has that symmetry. And this is what we mean when we say symmetric with respect to the x-axis. If you folded it here, and then you had this part come down onto this part, then they would match up completely because they're symmetric. This one's a little bit harder to see, but it's not too difficult. Imagine you cut this out with scissors and you had a piece of paper, and then you just stuck a pin here where I put the dot at the very center, at the origin. You stuck a pin in and pinned it to the wall, and then you were able to spin it around, like this. Spinning it around. If you spun it 180 degrees, this point would land right here. If you just completely rotated it half a circle all the way around. And then this point would land right here. And this point would land right here. And in fact, you would have a copy of itself if you rotated it about the origin. And when that happens, we say that it's symmetric with respect to the origin. Now, testing symmetry graphically, visually, is easy. But what we really want to get good at is testing for symmetry with just the equations. And here are the tests. If you want to test to see if there's any symmetry about the x-axis, then you replace the y with negative y. If you want to find out any symmetry about the y-axis, replace x with negative x. And if you want to find if there's any symmetry about the origin, do both of the above. That is, replace x with negative x and y with negative y. Great. And then you see if the new equation you get is the same thing as the old equation. Let's check it out. For example, let's test y equals x squared plus 2 for symmetry with respect to the x-axis, y-axis, and origin. We're going to run all 3 tests that we talked about earlier. And now check this out. Now, you can just look at this, and you can see that, yes, if you fold it here and flip it over, then yes, it is going to be symmetric about the y-axis. If you try and flip it over the x-axis, it is not going to work. And if you try and rotate it around the origin, you wouldn't get any copies until you get back 360 degrees to the original. So just right away, visually, I'm going to say that it is not symmetric about the x-axis, it is symmetric about the y-axis, and it is not symmetric about the origin. Visually, I'm going to say that those are the answers. What we really want to do is we really want to get good at testing for these things with just the equation. Pretend you didn't have the graph. Pretend you didn't know what it looked like. Here, if we're going to do this, we have to replace the y with negative y. So we're going to replace that with negative y, and let's see if the new equation is equal to the original equation. Well, multiplying both sides by negative 1, you get y is equal to negative x squared plus 2, and so no, it is not, because this does not equal this. They're not the same equations. Wait a second, this should be a minus. All right, now this is your chance to shine. I want you to show the work. I've taken a guess based on the graph, just looking at it, that I think that it's going to be symmetric with respect to the origin. However, I want you to show it and show that the answer is yes. So go ahead and start assignment 2D1 in your composition book. I'd like you to copy the problem list and do the first problem. And I will see you in class. Take care.